Lesson 12.2, Task 3. Add and subtract rational expressions. When adding and subtracting numerical fractions with unlike denominators, if you find the least common denominator, your LCD, of the fractions, then the resulting sum or difference is usually a fraction in simplest form. The same is often true when adding and subtracting rational expressions. All right, so they give us a rational expression here, and they go through the steps, but let's look at how to do it ourselves. It's always beneficial to actually work it out and not just look at it, because I feel like looking at math, you don't learn as much as doing math. So let's do it. All right, so the first thing is I just wrote down the problem. And then we know with adding and subtracting fractions, we have to get a common denominator. So what I'm going to do is see if I can factor the left side. Okay, so if I can rewrite this term here, I can factor out an x. So let's just rewrite this in factored form. So x times x minus 1. And I didn't change this, so I don't have to change the top. All I did was rewrite it in a different form. Okay, now when I do that, I can see that these have a common factor. So now I have a 1 as a placeholder on top, and the common factors will reduce. So let's rewrite this, clean it up a little bit. All right, so I have 1 over x, and then plus x plus 2 over x plus 1. Now I want to find a common denominator. Okay, I cannot just add 1 to both sides because I can't turn a monomial into a binomial. All right, so we have to multiply the left side by this denominator, which is x plus 1, and we do it on top and bottom. And we multiply the right side by the denominator over here, which is just x. All right, so now I'm left with x plus 1 over x times x plus 1. And remember, the order I write these doesn't matter because multiplication is commutative. I just like to have my monomials in the front anytime I'm working with them. All right, so now I have x times x is x squared. Think about this as being all together. You have to multiply all of that. So we're going to have x squared plus 2x. And then again, that's over x times x plus 1. Again, I just use commutative property to put those together. Now I can see that I have one common denominator, x times x plus 1. So that means I can add my numerators. So I'm going to have x squared, always put my largest term first, and then x plus 2x would be 3x, and then I have 1 left. Now, you may try to factor this, but you got to multiply to get 1 and add to get 3. The only thing that multiplies to get 1 is 1 and 1, and that's not ever going to give you 3. So this is in simplest form. There's nothing else you can do with this expression. And if you see, they stopped at the same place. Okay? All right, so that's how you add and subtract rational expressions. Get a common denominator, then add numerators, simplify if possible. All right, how is it beneficial to have factored the denominator of the first rational expression as the first step? Select all correct answers. All right, so by factoring this first, it also allowed us to reduce. So the factored denominator has an x minus 1, which is a term that appears in the numerator. That is correct. It is the only way to find a common denominator. By factoring, the first added is simplified to 1 over x. Okay, so that is true because we did simplify to 1 over x here. And then the work in the remaining step is simpler. That's true. If you reduce as you go, it makes each step a little simpler as you move through the process. All right, it says, what would the LCD have been in the third step if the common binomial factor had not been divided out of the previous step? Okay, so if we had not divided out the x minus 1 here, our common denominator would have been x, x plus 1, and x minus 1. So that would have been this step here. And then it says, why is it a good idea to leave the denominator factored in the final step shown? Well, in case you can factor the numerator further and reduce. Also, if it asks for restrictions, it makes it easier to see the restrictions. So let's see what it says. To see if there are any common factors in the numerator so the expression can be further simplified, that would be true. The product in the denominator cannot be rewritten using distribution. The denominator must always be factored. That's not necessarily true. It's nice having the denominator factored, but it doesn't have to be factored. Let's see, to change the rational expression into a numerical fraction. All right, so I think the best answer here is so that you can see if there's any common factors to further reduce. Is it possible to simplify the rational expression shown in the last step above? And I'm going to say no, because I already tried to do that. You can't multiply to get 1 and add to get 3. So it has to be one of the no's. No, the trinomial cannot be factored. No, the trinomial can be factored. So it cannot be factored. So that would be the correct answer there. All right, that is all for task 3. If you have any questions, please let me know. Lesson 12.2, task 4. Add and subtract rational expressions. Determine the difference from these two expressions here. All right, so we're trying to subtract, and let's go ahead and look at it for a second. So we're going to do x plus 2 over x squared minus 2x minus 15 can be rewritten in factored form, and that's going to be x times x. 15 is 3 and 5. I need a negative 2, so we're going to rewrite it like that. All right, on this side, so this one has to be factored a little bit differently. Let's go ahead and bring it over here. So we got 2x squared plus 7x plus 3. This one takes a little bit more work because it has a leading coefficient other than 1. So we have to multiply this 2 by 3. So we're looking for a number that multiplies to give me 6. 2 times 3 is 6, and we need to add to get 7. So that's going to be 6 and 1. So we're going to rewrite the middle term as plus 6x and plus 1x plus 3. So all we did was rewrite the 7 as 6 and 1. Now we have 4 terms, so we can factor by grouping. Bring out my 2x. I'm left with x plus 3. Here I'm going to factor out a 1, and I'm left with x plus 3. All right, so 2x plus 1 is one factor. And x plus 3 is my other common factor. All right, so this denominator here can be written as 2x plus 1 and x plus 3. And you can quickly check that. I mean, 2x times x is 2x squared. Then I've got 6x plus 1x is 7x in the middle, and 1 times 3 is 3. So that's easy to check. And that should be a 3. It doesn't look like a 3. All right. Let's see what the questions ask us from here. It says match each step of the subtraction process with the number that represents the order in which each step is completed. All right, so the first step we rewrote it in factored form. So let's see if I can do this here. All right, and then what are we going to do from there? We are going to get a common denominator. So we have to go down here and get a common denominator in both terms. All right, and then the next step would be putting the two fractions together. So we're going to go with this step, I believe. And then we are going to multiply these two binomials together to get this here. So that should be our next step. And then when we just rearrange, simplify all this, the 2x squared minus 5x squared becomes a negative 3. That should be our final step. So instead of working this one out this time, they just had you choose the steps that you do. So you would work it the exact same way. So you factor it first. You see that they do have a common factor of x plus 3 on both sides, but then you would have to add a 2x plus 1 here, and you'd have to have an x minus 5 here, which is what they did in this process. All right, match the justifications for the steps with the number that represents the order in which each step is completed. All right, so what did they do first? All right, step 1 was right here. So the first thing we did, I would think, would be get a common denominator. Subtract the numerators, distributive property, use the common denominator, combine like terms, factor the denominators. All right, so we did have to factor before we got a common denominator. So remember here, I did have to factor first, so this probably is the first step. So we did go through and factor. And then we would use the common denominator after that. And then we would subtract the numerators, because that's what we do to solve the problem. Then if you need to, you would, let's see, would we use distributive or combine like terms? I think we would use distributive property. Without having it worked out, let's see what happens. Okay, we got that correct. So if you go back up here and look, we can see that the very first thing we had to do was factor our denominators. Okay, I started that process right here. So let's see, step 1, we factored the denominator here. And then step 2 was we got the common denominator. They added the term that was missing from both sides. And then 3, they combined the numerators. So they put it all over one denominator. And then the next step was to distribute. So here they multiplied distributive property here. And then last they did combine like terms. So that's why I went with distributive property and then combine like terms next. All right, that is all for task 4. If you have any questions, please let me know.